So these are two ASs. So BGP is written as BGP, but it is understood as so whenever we say BGP, it is understood that BGP means eBGP and iBGP. E stands for external and I stands for internal. And normally when we say BGP, it is understood that we are talking about eBGP. We say it is not worth mentioning that actually BGP consists of eBGP plus iBGP. It is not worth mentioning because that is a universal truth. But whenever we talk about specifically BGP operation, more specifically, we are talking about eBGP. So that's how the name goes. So inside an AS, I may have OSPF, or I may have EIGRP, which is distance vector. I did not write RIP because with RIP, then I have to put an assumption that I'm a small organization with up to 15, 16 hops. So that's why I'm picking up EIGRP. So these are called IGPs. So these protocols are again for internal. So OSPF, EIGRP, RIP, they are called IGPs. And BGP is having two parts, eBGP and iBGP. Now, you should be very clear about some misconception about BGP. So how that works, that BGP has two parts. So if I am connecting these two ASs, so I have a router here, I have a router here, then they would speak to each other with eBGP. eBGP cannot work if inside I do not have iBGP. So in order this eBGP to work, inside I should have iBGP. So it means inside I will have two protocols. I would have an IGP, for example, this, and iBGP. I will have an IGP, one protocol, and iBGP, second protocol. Okay. Why BGP is divided into, so I will come the first point earlier, I talked about later. So why once I already have IGP inside and why I need to have iBGP then. So if I'm having an OSPF outside, right? So I'm having OSPF, inside, and if I get routes under eBGP, right? So I can, OSPF supports redistribution. right? OSPF supports redistribution, EIGRP supports redistribution, even RIP version 2 supports redistribution. So I can just redistribute, I can do the redistribution of EBGP into OSPF. So I can just take the EBGP, redistribute it into OSPF, which technically is not impossible. Then why I have IBGP in addition to IGP mean OSPF? So this is one thing we would try to understand. Anybody has an idea? People who have done kind of those CCNA, CCNP things, they must know. No? Okay. So I give you a couple of reasons. One reason is protocol translation. So EBGP is distance vector, like RIP. OSPF is link state, and you have analyzed both of them. And if you imagine a distance vector packet and OSPF packet, you can imagine how many translations of different fields has to be done to go from one to the other. So every organization communicates too much with the external organizations, with the rest of the organization in the internet. So there would be too many packets which would be coming through EBGP, and you have to translate them in OSPF, and that would be costly. Now, not to simplify the process, uh, my router is already, talking with millions and billions of packets, and if I have to translate them on top of it, it would be just dead. This is one reason. I don't want to do the protocol translation of redistributing routes from EBGRP to RIP. Reason number two is the scale. Scale. So what I would like you guys to do is open a browser and search up BGP table size, real-time BGP table size, something like this. And click on first or second link, and it would show you the number of BGP routes in real time. And you would find them, they are from 7 to 800,000 records, usually. So go to the browser, search their BGP, real-time BGP table or table size or something. And you would get a link for CIDR or CDI or something like that. And if you open up, you would see that number of BGP routes in real time at this time in the world, they may be around 7 to 800,000 records. If you import those many routes into OSPF OSPF would be killed. OSPF cannot handle that volume of rules, right? So without complicating the situation, so I'm giving you only two basic reasons. Because the scale of EBGP is very high. Anybody who has seen that size or not?
Yes, saw.
So what's the number?
More than 800,000.
There you go. So I taught the course 6 months back, so it was like 7 to 8 then, and now it has gone to over 800,000 records, right? So due to the scale and due to avoiding of the protocol translation, we have IBGP inside, right? So everybody understand the reason why BGP has two parts, why inside I have IBGP. Yes? One yes would work. Okay, good. So now I go inside again. Let me draw again. Okay. So now here I'm talking about the relationship between IBGP and IGP, right? OSPF, for example. So what we would have from outside, I will get EBGP. Inside, I will just talk to my brother, IBGP. Okay. EBGP and IBGP. Also, we should talk about. This is one thing we would talk about. We would also talk about relationship of this, and we will also talk about relationship between IBGP and EBGP, right? So EBGP, IBGP, they are same protocol. So they are distance vector. Distance vector means they have the potential of having loops. All the distance vectors, they have potential of having loops. So it means they should have some mechanism to avoid loop. If they are the same protocol, so they would have the same packet format, right? They should have same packet format. How they are different? They differ in their scope. They differ in their scope. One scope is internal, the other is external. And then they differ also. Internal and external, they have different rules. Different rules due to the difference in scope. Due to the difference in scope, they have different rules. And there are some common things, so I'm on the same topic. So there are common things as well. Common things is if IBGP and EBGP, they are the same protocol. Uh, I always focus on, whenever you look at a protocol, we should look at what is the routing objective. For example, we define that in unicast, our routing objective is to find least cost paths to every destination possible. In multicast, I explained to you that my routing objective is to form a multicast tree where I'm evaluating the cost of a tree starting from a source going to all those nodes which are part of my multicast communication. So out of like a big tree with many branches, I will select some of the branches so that I can connect a source to some selective links out of many links available in that entire network so that messages could go from the source to the destination. Similarly, routing objective of a BGP is different. So I take you to the older picture here. Uh, what kind of link is this? EBGP link. What kind of link is this? Or what kind of network is this?
Point to point.
Point to point. So in BGP, neighbors are, what is in point to point? Neighbors are directly connected. So in BGP, I would not say always. I would say neighbors are usually directly connected. Okay, if the neighbors are directly connected, then what are my routing needs? But usually what in my previous examples, I'm missing an E there. In my previous examples, for example, in unicast routing, my need is that I don't know indirectly connected destinations. So I want to reach them through my directly connected next hops. Same was true in multicasting, but now I have a different problem. My destination, my neighbor is directly connected to me. And I do not go beyond. So as EBGP, I do not go beyond this. Beyond this, that's what EBGP is. So this point to point link. So usually in BGP, the neighbors are directly connected. If the neighbors are already directly connected, and my only concern is to connect two ASs. So from one autonomous system border router to other autonomous system border router. So these are two ASVRs. So my only job is to connect those two ASPRs in an external perspective. So I'm already doing that. So then why I am there? What is my routing objective then? That's what we are going to understand in this next segment. And then I will come back to the relationship between IBGP and IGP a little later. So because I started talking about this now. Okay, right. So then what is the routing need? So I would say, what is the routing objective of BGP then? Any guess?
Uh, there are multiple routes, so it gives us the best route, the control over which packets are gonna flow to the neighbor
Yes.
autonomous system.
Yes. So routing need is the only job I do as BGP is that I may have more than one incoming or outgoing interfaces. So my job is to prefer one over the others. Prefer one interface over the other interfaces. This is my job. How I do that? Based on how we differentiate two entities. So I know in the previous class there were a couple of, I mean, your course buddies. So some of the people, they were married. Anybody married in this class? No one married. Oh, okay, cool. So let's say, okay, if Dolly Nusha, so Maridani is saying Dolly Nusha. Okay, Dolly is there. Okay, there we go. So we have a sort of, okay, Dolly. If it's not personal, was it an arranged marriage or it was a love marriage or semi sort of?
Yeah, it's arranged.
It's arranged. So when your mom and dad and your family were looking a match for you, what they were looking for? That was the only match you guys looked at, or you looked at, you know, more than once, and then you said, no, this gentleman.
I mean, parents look for multiple and they have
Multiple,
choice.
there you go,
Yeah.
right? So whenever we have to make a choice, we will have multiple options, and then we evaluate those options. So if we are looking for a match for ourselves or someone in our family, we should look for, okay, I mean, we should look for, yeah, with you, I was talking. We can look for some functional traits. We can look for some non-functional traits, right? So, and depending on our family needs and looking at, we will see how the person looks like, how the person's career is, how the family is. So there's so many factors. So then we choose, no, this is the person which suits best for me, for my daughter, for my son, for my sister, whatever the way the family works. So that is the job of BGP. So BGP has more than one options to choose from. It will choose only one based on 10 to 11 factors, which are listed at the end of PowerPoint in BGP, right? So I would say, oh, I would do, let's say, based on first, okay, I have two people to choose from on physical basis. Let's say, I would say, oh, they are same height, same color, same everything. Oh, it's so hard to, you know, reject anyone. I say, okay. So on physical appearance and handsomeness, whatever, they both the matches are equal. So let's look at something else. Okay. Oh, the one person has both the people have, let's say, good IT career. And they're almost at the same designation, and growth rate might be same in future. No. This also is not working. Okay, let's look for another sort of trait. Okay, is he from my family or caste in case if it matters? Or say yes. So one person is from my family or caste. Okay, reject the other person. So you are looking for some criteria where you would break that high, and this is the job of BGP. So the job of BGP is not to look for destinations, because destinations are always known to BGP. Why? Because they are directly connected. They are point to point, usually. So job of BGP is that if I have more than one outgoing or incoming, and it's doing it for both cases, right? So every interface is, as I explained to you in the beginning, every interface is incoming and outgoing, right? So because I receive and I send. So that's what the job of BGP is. The routing objective of BGP is to prefer one interface in either direction over the others. Now, If I'm in a situation, I'm AS100, I'm AS200, and that's the only link I got between us. The question is, do I need BGP or not? Right? I would say not. Why? Because my job is, if I have more than one option to choose the best option, there's no more than one option, so I don't need it. You may say, okay, if this AS is my service provider, how I would connect with the service provider, right? So I would say with the combination of default route. Oops, I messed up. With the combination of default route and static route, I can configure this point-to-point link. So I don't need BGP, right? So BGP is not there because I have an external connection and I would have BGP. No, yes, Sukdeep.
What if those two AS are using different protocol? Like suppose one is using OSPF and one is using EIGRP.
Yeah, but you can do redistribution, we said earlier. If it's just a connection, just a matter of me connecting to someone, if they are using different protocol, then we can do this redistribution. Redistribution is okay. We are scared of doing redistribution of sort of BGP stuff because that's very high in scale, and that would kill the OSPF, where I can have only about what 50 to 75 routers in one area. And I'm talking about a limited network. When I have a limited network, I'm talking about a limited number of records. I cannot handle those, hundreds of thousands of records. So then I would be doing redistribution, right? Similarly, BGP is also not used for backup. If my purpose is, I was with one service provider, and later on I thought, okay, the service is shaky, so why not? I'm AS100. I'm connected to one service provider, and then I'm connected to another service provider, and I thought this is not reliable. So this is not reliable. I should have another AS. I should have another service provider, one service provider two. Then even I do not need BGP. So I have a backup link with one service provider. Now I have three options. Still, I do not need BGP. So BGP is not for redundancy. It's not for backup. Well, BGP, if I have these situations, I do not need BGP. I can survive with the other strategies I mentioned to you. I can do redistribution. I'll be working fine. Okay, so I need BGP where I'm really connected to, there are two service providers and they are connected to sort of the word out there through someone. Then I'll be needing BGP. So I will go to the core of the BGP. Core of the BGP is that neighbors are directly connected. They are point to point usually, and the routing need is not routing in conventional means. It's only the preference of one out of many options based on certain traits, based on certain parameters. That's what BGP is. Any question? Now I go back to the point which I mentioned here. What is the relationship between IBGP and IGP? Now I'm coming inside. So when I come inside, so if I'm BGP, the same rule would apply for IBGP. So one of the rules for eBGP is that it should be directly connected. So inside, I make two networks. So I have an overlay overlay that is IBGP, and underlay is oops, my underlay is missing a few letters. And my IBGP is underlay. So now, if EBGP has to be directly connected, IBGP has to be directly connected as well, because I said it's the same protocol. So let's say I have 3 routers inside. So this is one router. And to make it sort of a good BGP case, then I have to sort of put another link, right? So that, as we discussed earlier, so I should be a case for this. And then to make it simple, let's say I have another router here, and this is my topology. So I can arrange my IBGP in different ways, but I will go with the basic way here. So in order to make this to be IBGP, I would sit here and I would say these 2 routers in green line, they are neighbors. These 2 routers in this green line, they are neighbors. And then I would say these 2 routers, the dotted line, they're also neighbors. Are these 2? Let me number them. So it's getting a little complicated. So I would say R1, R2, R3. So that would tell you if I'm a point-to-point network, can you imagine how the configuration would look like, sir, for clear understanding? Any real-time examples? Arvind, what kind of examples you are asking for real-time? Arvind?
Actually, when you were saying like when two autonomous systems or like when 2 or more autonomous systems are there, so there's not necessarily like we needed to give BGP. So
Yeah, the
that means
example of that would be, for example, if I am Dell, so I'm taking service from Alliant. I'm also taking service from Eastlink. Okay, so or I'm Eastlink. I'm connected to other companies. So sometimes I would be I need a little bit more something to give an example. So it's a little premature. So we need to know a few more things, for example. So I will give you examples if I'm just explaining very basic things. So if you give me a little bit more time, so you remind me again if I don't give anything, because we need to know
sure,
more
okay, sir.
things to understand. So for the time being, we are understanding very basics. Okay. So I will change this color. I will keep the same color. Oops. Oh, oops. Uh, I forgot I was outside, I guess, right? Yeah. Okay. So I will keep the green. So I would say, so all these green things, they are overlay. You see, I have 3 links in overlay. This is one link, this is second link, and this is third link. I'm okay with link 1 and link 2 because they are directly connected, because I have those black links between R1, R2, and R2 and R3, right? And the third link is between R1 and R3, and R1 and R3, they are not directly connected through a physical link. Is that correct? Yes. So then the question comes, If a packet has to be routed from R1 to R3, in the software I told them, okay, so in the software I told them that R1 is neighbor of R3, and then I set on R3 and I said R1 is neighbor of R3, and I set on R1 and I say R3 is neighbor of R1. So I have configured this overlay green network. That would also tell you what configuration in BGP means. In BGP, the configuration means only to declare neighborhood. In BGP, configuration means only to declare neighborhood. If I'm doing eBGP, I'm making neighborhood between 2 point-to-point routers. So I would sit on this router, I would say that router is my neighbor. I would sit on this router and I would say this router is my neighbor. Same I would do inside. I sit on R1 and I say R3, R2 is my neighbor. Then I say R3 is in my neighbor. I sit on R2, I would say R1 is my neighbor. I say R3 is my neighbor. I sit on R3, I say R2 is my neighbor. R1 is my neighbor. The only configuration, basic configuration in BGP is just declare neighborships and that's it. And you have two types of neighbors, obviously. I may have external neighbors or I may have internal neighbors. So if I'm doing IBGP, I'm dealing with internal neighbors. Why I'm calling them neighbors? Because I'm BGP. My job is to make neighbors. So my overlay would be green. So the question I was asking is how a packet, let's say I receive a packet. If I receive a packet from this side and the packet has to go out from this interface, how this packet would route from R1 to R3.
From R2.
Yeah, it would go from R1 to R2, then R2 to R3. So that's what has been sort of physical movement of the packet. But logically in IBGP, the packet has gone directly from R1 to R3. Logically, the packet has gone through from R1 to R3 directly through this neighborhood, which we created. I marked as 3 in green. Logically, it will go through here, but physically, it will go through R1 to R2 to R3. And this is the relationship between these two.
So from R1 to R3, will there be, it's kind of virtual link?
Yes.
Okay.
Yes. So overlays are many of the overlay links are always virtual. So I satisfy the software. So because software wants, so if I'm BGP commands, which iOS gives me, Cisco iOS gives me, so BGP says you have to declare a neighbor. So R1 to R3, I have to declare a neighbor. R3 to R1, I have to declare a neighbor. If I don't do that, BGP would not be configured. So you are satisfying the software. So that's what builds that green overlay. But if you have to go to one point, which looks like a virtual network, virtual link, you would, in IBGP eyes, you would go from R1 to R3, but there is no direct connection between R1 and R3. That's where the role of IGP would come. If IGP is not there, then you would not do that routing. So does it work like hub and spoke? No. In this scenario, it does not work like hub and spoke. It works as overlay and underlay. There is a scenario for hub and spoke as well. Right? So at this moment, I want you to understand what is the connection between the IBGP and IGP. So in IBGP, we build an overlay. And an overlay, for example, if I take you here. So I have these two exteriors. I have now. Okay, so I have R1, R2, R3, R4. These are my exteriors, right? So this is an AS. Now I have 4 routers. So when it comes to, you see, I told you that there are more rules for BGP, right? If you mentioned earlier when I was talking about IBGP, BGP, I said IBGP has more rules. So I'm revealing some of the rules. So on top of the previous information I shared with you, I would say it is one of the rules in IBGP that you should have a full mesh. Full mesh in where? In that overlay. You should have full mesh in that overlay. This is one of the rules. Okay, full mesh in overlay. What does that mean? If I'm here, if I want to build overlay, first I will build this link, this link, this link, this link, this link, this link. So I will build all these neighborhoods among
So
all
these
those.
would be virtual links between like
Yes,
R1 to R4.
yes. So wherever the link is not there, obviously that would be a virtual link. So my overlay, now if I divide them, would look like this. So my overlay would look like this link, this link, that link, that link, this link, this link. This is my overlay. And my underlay would look like this. Oh, let me use the other color. My underlay would look like this link, and this link, right? So when I want to send a packet from R1 to R3, from overlay, it will directly go this route in virtual word and logical word, but physically it will go like this. It will go like this. So I want this, I want here, I want something to happen. And it happens. I am imagining go from R1 to R3, but the implementations happen here. The physical, real movement of the data or packets, it happens here in the underlay. Underlay is IGP and overlay is. So when you would do BGP lab, first you would configure OSPF. First you would configure OSPF, because if this is not there, OSPF is not there, then this will not work, because they both have to be there. So your first lab would be OSPF. Then you would go to BGP. First thing you would do is you would do OSPF. You would not go with the speciality of OSPF areas and all those kind of, stubby and those areas, but a simple OSPF so that you have your network working, so that you have your IGP working, because without IGP, IBGP cannot work. Why? As I explained earlier, this is a different protocol. Okay. This is a different protocol. And what is the routing objective of this protocol? It only understands directly connected hosts. What is the routing objective of OSPF? It can find out indirectly connected destinations. So they have two different routing objectives. I want to use the routing objective of IGP, OSPF to my advantage as IBGP. So that's why I make an overlay network and I go logically from one point to another point, and I assume I'm connected to other routers where I'm not physically connected, I'm connected virtually. In order to materialize that virtual imagination, I make use of IGP because IGP is able to go from a point to an unknown destination or destination which is not directly connected. So that is the connection between IBGP and IGP. Yeah, good. One yes would work. Okay. So now imagine this company to be Zoom, and COVID is happening. Oh, let me change the color. I was a small company. I had 4 routers. COVID came, and I have 2 exteriors. I got a growth as Zoom, and my routers grew from 4 to 400. And I hire you, and I tell you now they are not 4, they are now 400. And hire you, say, okay, can you do a full mesh for me for 400? How easy the job would be. So I want to configure IBGP. I want to have a full mesh because this is one of the rules. And I hire you. I said, okay, build me n into n minus 1, or maybe over 2, or 2 would not be there. Those many adjacencies. Right? So can you imagine how difficult or near to impossible that work would be to do? Because I have to remember and document all those, and I don't think I can get away without making mistakes. So as the size of the network grows, that means scalability varies. Full mesh becomes hard to manage. So BGP has a challenge uh, that is called BGP scalability. BGP scalability has many issues. By scalability, I mean, as I gave you, okay, let's say you were Zoom, nobody was using you, COVID-19 happened, everybody started using you. One way of understanding the increase in business or utility would say, I have to grow from 4 routers to 400 routers. And if in my IBGP still I need to make full mesh, it would be next to impossible to make. So BGP has issues, inherent issues with scalability. So then there is a range of things we do to manage. The range of things we do to manage scalability in IBGP. So for say, I say it is very simple protocol, you just create neighborhoods. But when it comes to manage the scalability of BGP, then it becomes very complex. That's why in most of the organization, only very senior engineers, they get the role of a BGP configuration. Okay. And we will talk about them. So one of the hint here is that, of course, if full mesh is not manageable, and many of the organizations are large size organizations, they will be having tens and hundreds of routers. Then what do we do? So then there are alternatives. There are alternatives to full mesh. So you don't do full mesh. You do other techniques in order to deal with the scalability. We'll talk about that in the third segment of BGP. But here, I told you how IBGP work, how the overlay and underlay work together, what is the relationship between IBGP and IGP, and then I gave you an example how scalability could be a challenge. And then I hinted you that there would be a few things we will cover related to managing the scalability of IBGP. Okay. What else I should be saying? Now it is very obvious. It is very obvious that nature of BGP is based on neighborhoods, also called peership. Okay. And neighborhoods or peerships are of two types: external, internal. Right? So here, so these are two external neighborhoods, and all these four or six, they are internal. Internal neighborhoods. Right? So two types of neighborhoods are peerships. Right? So peership is more technical. So from a configuration point of view, what does that mean? That I'm just declaring neighborhoods, nothing else more than that. Okay. So with this primer,